Are you in control? Hormones, the brain, and your metabolism. Let's get started. So the first thing that we're going to talk about is the brain. And believe it or not, the human brain has a lot to do with fat metabolism. Now, we're going to talk about one specific piece of the brain, and that is the hypothalamus. Now, the hypothalamus is located in the forefront of the brain and has lots of functions having to do with hormones. But we're going to be focusing on one part of the hypothalamus, which is the ventromedial hypothalamus. What is the ventromedial hypothalamus? The VMN, the ventromedial nucleus, as what it's really known as, is constantly searching for the leptin signal. So let's go through the relationship between leptin and the hypothalamus, more importantly, the VMN, the ventromedial nucleus. So the leptin hormone is going to send a signal to the VMN, the ventromedial nucleus within the hypothalamus. Now, once it sends that signal, the nucleus is going to see a message that states, enough energy is stored and you can now burn the excess. It's time to feel good. Long-term food intake decreases and you are weight stable. So all four of these things sound a lot like weight maintenance and weight loss. So for a moment, if you can imagine, what if leptin was dysfunctional? What if something was wrong with the leptin hormone? What would happen? Let's go through it a little bit. So let's first talk about the fat cell. Now, what's really interesting about our fat cells, our adipose tissue, is that they actually store and create leptin. So let's take a look here. We have our fat cell, and our fat cell, through the use of leptin, which is in each of your fat cells, is going to send that signal to the hypothalamus. So leptin serves as almost a thermostat for the hypothalamus. So it's telling the hypothalamus what it needs to do with these fat stores, and who better to do that than leptin? They're actually in the fat cells. They have experience with these fat stores. They actually know what's going on. They're down there. So let's talk more about that. So we have a leptin signal. And if you get a leptin signal, if you have enough fat stores where you're not hungry and you can burn the excess, you're going to get a leptin signal, and that leptin signal is going to state to the hypothalamus that you're not hungry and you're ready to burn energy. Now, what if you don't get a leptin signal? Now we're talking about if there is a dysfunctional pathway here with leptin, like we mentioned before, what happens? So if we don't get a leptin signal, what's going to end up happening is you are going to be hungry and you're going to go into storage mode. So this is very important to take note of. So no leptin essentially means that you're going to be hungry and you're going to be going into storage mode. So let's look at it from the fat cell's perspective. So we have our current fat cells right now, and that's pretty much making up your adipose tissue, your fat cells surrounding your body. So this is the current state as we speak. Okay, it sends the signal to the hypothalamus, and let's look at two different scenarios. So what if the hypothalamus does in fact receive that leptin signal? What happens? Well, if it receives the leptin signal, what's going to happen is there's going to be excess energy, you're not going to be hungry, and since there is excess energy, you're going to have to use that, and that's what the hypothalamus is going to do. It's going to pretty much dictate the pathway you're going to take to decrease fat tissue. So we're moving down, we have a leptin signal, and as you can see, fat tissue decreases. So if we have a leptin signal, we're going to be set up very nice for us to decrease our fat tissue. Now, what if we don't have a leptin signal? If we don't have a leptin signal, that means we are going to be hungry and we're going to be in storage mode. And as you can see, the fat cell increases. Now let's take a look at if we had a leptin signal, and we're going to go ahead and move the decreased fat cell that we had over here to actually now our current state. So now this current fat cell sends a signal to the hypothalamus, and the state goes on and on and on. You can either continue to decrease with good leptin signaling, or you can continue to increase if leptin signaling is not received from the hypothalamus. So as you can see here, we have either a leptin signal, and with our current state, it would decrease providing we know this information and we use it correctly. And if we don't have a leptin signal, we'll just go back to our state previously. We'll just increase that adipose tissue again and we'll just gain that weight back. What I want you to take away from here is leptin signaling is key for you to start the process of taking out fat to use as energy from your fat stores. So let's look at the two pathways that we would take if we have a leptin signal and if we don't have a leptin signal. So we have the hypothalamus here. Okay, now if we have a leptin signal, we're going to take the pathway of the anorexigenic pathway, which is you're not hungry and you're ready to burn energy. Now if you don't have a leptin signal, the hypothalamus doesn't pick it up, we're going to go through the orexigenic pathway, which is you're going to feel hungry and you're going to be in a state to store energy. Let's take this a little further. So what does this mean to take each pathway? What happens? Okay, so this might seem a little intimidating, a little complicated, but it's actually not that complicated. So let's go through it together. So we have the hypothalamus. The hypothalamus receives a leptin signal. Okay, so we take the anorexigenic pathway. We're going to turn on the sympathetic nervous system. That's what this green arrow is here with this plus sign, turning it on. And we're going to turn off the vagus nerve, the parasympathetic nervous system, with this minus sign signifying we're going to turn it off. Okay, and if we were to take the orexigenic pathway, which would be you're hungry and you're ready to store energy, you'd do the opposite. You would turn on the parasympathetic nervous system and you turn off the sympathetic nervous system. Now, all of this stuff isn't too important, but if you really understand the pathway and what's going on here, you're more primed to really make this change. So stick with me here. So we've got now these two pathways that are going to either take from the fat cell or going to add from the fat cell. So let's talk about that. So let's go back to the leptin signal. We'll start from the beginning now. So we have the hypothalamus, the brain, okay? It receives that leptin signal saying, look, I'm not hungry and I have excess energy. Let's go ahead and burn it. Let's take it from the fat cells and use it, meaning we're gonna lose fat tissue. So again, we're taking that anorexigenic pathway, the not hungry / burn energy. We're going to turn on the sympathetic nervous system, which is going to get the muscles firing and primed to expend energy. We're going to turn off the vagus nerve and we're going to continue using the fat through that fat cell. And it's going to continue in a cyclic manner perpetually since we have leptin here. Leptin again is being detected by the hypothalamus and we will continue to go through the anorexigenic pathway. So let's talk about if we're going through the orexigenic pathway or you don't have a leptin signal. So here we have the hypothalamus. There is no leptin signal to be found, which is going to mean that we're hungry and we're ready to store energy. Okay, we're turning on that vagus nerve, we're turning off that sympathetic nervous system, and we're going to be adding with that plus sign to that fat cell. The fat cell is going to volumize, get bigger, and our fat tissue is going to increase. We're going to gain weight. And then, of course, we have insulin. Now, this really does throw a wrench into the whole system, and we're going to talk about why. So, what is insulin? So, insulin is a few things. Insulin is a hormone created in the pancreas that regulates the amount of glucose in the blood. Insulin, a hormone created in the pancreas that is responsible for the storage of energy in your liver, muscles, and adipose tissue in that order. And insulin, a hormone diabetics inject following consumption of dietary carbohydrate in order to lower their blood glucose. Now, all three of these are correct, and I put all three of them out there because I really want you to take notice of something. Two of them are very well known in our society, and one of them kind of falls in the shadows a bit. A lot of people don't know that this is really the case with insulin. So they're all correct, but one of them we fail to really take a look at, and that is insulin, a hormone created in the pancreas that is responsible for the storage of energy in your liver, muscles, and adipose tissue in that order. Let's talk a little bit more about that. So, insulin discontinues any and all fat mobilization, fat burning. So, when insulin is secreted in large amounts or when insulin is starting to be secreted, fat mobilization is going to decrease. Insulin turns on the vagus nerve, which is the parasympathetic nervous system that we talked about. If you don't have a leptin signal, the parasympathetic nervous system is turned on, which is that vagus nerve. It accelerates insulin production with the priority of conserving energy. More insulin equals more fat. So, time to take notes. More insulin equals more fat. Insulin is the fat storage hormone. Period. End of discussion. It's really the only thing that you need to know about insulin as far as our goals are to lose fat tissue. Energy expenditure is decreased by 20% induced sloth. So I put induced sloth there because it really isn't your choice. This is done against your will. Once insulin is secreted and the pancreas is revved up to create lots and lots of amounts, especially if you're having lots of refined carbohydrates, meaning like boxed items, things with nutrition labels on them, if you're eating large amounts of those, the pancreas is constantly going to be revving up, overproducing insulin, because it's possible that at this point in time, you might be needing more insulin to have the same effect as, let's just say, you used to when you were a kid. You're becoming more insulin resistant. So energy expenditure is decreased by 20%. Basically, since insulin is the storage hormone, it's going to say, look, all right, we're going to shut down all fat mobilization. You're not going to be using fat as energy. And not only that, we're going to do it by way of you not expending any energy. So if you think you're going to the gym right now, nah, sit your ass on the couch. I'm not giving you that energy. You're going to feel like shit. Don't move. That's basically what happens. Anything where you felt lethargic throughout your day and you're like, I don't understand. I don't know why I feel like I don't have any energy. This is basically what's happening if you're having a large percentage of carbohydrates in your diet. When is insulin released? Insulin is released directly after the consumption of carbohydrate. Put that down. Remember that. So remember everything that we talked about regarding insulin, and when it is going to be dispersed into the body is when you consume dietary carbohydrate. Insulin is the fat storage hormone. It is dispersed immediately after carbohydrate is consumed. Yes. Period. Aha moments out there? Maybe? Perhaps? Okay. All right, so let's move on. So let's talk a little bit more about insulin relative to what's happening in the pathway that we talked about. So here we have insulin, okay? Just pay attention to it right there. And basically what you see here is an X. That X signifies that if there's in fact a leptin signal, okay, the hypothalamus is not going to be able to detect it. So insulin masks leptin. So with insulin actively standing in front of leptin and standing in front of the ability for you to be satisfied in full, sometimes it'll feel like leptin completely evaporates. Insulin takes the precedent in your hypothalamus and it's telling the entire body to go through the orexigenic phase, being hungry and storing energy, turning on the vagus nerve and adding fat to your body on a perpetual basis. So this just happens more often if you are somebody who is consuming carbohydrates, refined carbohydrates on a very, very regular basis. So let's go through it. So dietary carbohydrate. Basically what's going to happen is insulin is going to increase once dietary carbohydrate is ingested. Once it's increased, leptin is going to decrease. If insulin is present, leptin is not going to be able to be seen by the hypothalamus. Leptin decreases, then hunger and storage increases. Hunger and storage increases, insulin resistance increases. Brief definition of insulin resistance: you're going to need more and more insulin in order for it to be effective. Okay? Insulin resistance increases, leptin resistance increases as well. So remember this: insulin resistance causes leptin resistance. So there is no counting calories. That's not how this works. These are scientific principles that if you understand what is happening here, you're going to be more apt to make a change. Understand, when you increase your dietary carbohydrate consumption in your diet, and when they're refined, it's almost you almost have no chance. So let's put it all together. So we have leptin. It's going to signal the hypothalamus, and it's going to tell the hypothalamus that you're not hungry and you're ready to burn energy because you have some excess. You're ready to take from your fat stores. The hypothalamus is going to turn on your sympathetic nervous system, turn off the vagus nerve, and it's going to tap into your fat cell, decreasing the fat cell, losing fat tissue. Okay, this is what we want. Now let's just say we change, and now we have insulin blocking the leptin signal. So the hypothalamus doesn't get a leptin signal. We're turning on that vagus nerve, turning off that sympathetic nervous system, and we're increasing fat storage to our fat cells, increasing our percent body fat. So let's look at it from a fat cell perspective. So this is the current state of the fat cell. If we have a leptin signal, it's going to get smaller. If we are not hungry and we're ready to burn energy, and that's what the brain is telling the body, that's what's going to happen. If we have this knowledge and we use it and we change our habits, this is what's going to happen. Now, if there's no signal, it's only going to increase. If insulin is in the system and it's blocking that leptin signal, this is what's going to happen. And let's look at it from a perpetual standpoint if you're eating carbohydrates in high amounts. So we've got carbohydrates consumed here. No signal to insulin. So now our current state is a larger group of fat cells. Basically, your percent body fat increases. The amount of weight that you have now has increased. You've gained weight. Okay, so if you have a leptin signal, you'll just go right back to it, providing you do what's necessary. And then, of course, the whole system will follow itself. If you continue to consume carbohydrates in large quantities, insulin is going to block leptin, your ability to be full and burn energy and feel good. And what's going to happen is this is going to continue to grow. All right? If you're not burning fat from your fat stores, you're not losing weight. If the scale is going down, okay, but you're not sure if you're actually using adipose tissue, fat cells as fuel, you're not losing weight, okay? You could really just be losing water weight. You could be losing glycogen from your glycogen stores within your muscles. If you're counting calories and you're eating lots of boxed items, it's very likely you haven't burned fat in a very long time. So this change needs to be made. So what do we take away from this chapter? Consuming high amounts of carbohydrates, especially ones that are refined, is only going to increase your insulin secretion, which means insulin is your fat storage hormone. If there's lots of this in the body and it's constantly being secreted by the pancreas, fat mobilization basically does not exist. So let's remember that and let's take that on to the next chapter. Welcome back, everybody. So I hope you learned a lot on the hormones leptin and insulin. Remember, leptin is going to send a signal to the brain. The brain is then going to decide, are we going to conserve energy or are we going to expend energy? Remember, insulin, when insulin enters the equation, that equation is going to be much more complex. The next thing that we're going to talk about is dopamine, the neurotransmitter that is constructed in the brain. Now we're going to talk about the relationship between leptin, insulin, and dopamine. Essentially, your hormones controlling hunger and satiety, and then your brain, which is controlling that voice in your mind that says, just one more cookie. Let's learn about the relationship between these three and how important it is for us to move forward with our goals. See you guys there.